So what's up everyone? Welcome to salt analysis, and this is our first lecture. And basically, who should watch this series? Well, as I've written here that I'll give a timestamp in the comments to skip my yapping, but I would like to talk for a minute or two. Basically, this series is for people who have given up on salt analysis and they want to retrieve some marks, because JEE Mains will ask a question on this most probably in every shift. So this is for those who have basically given up on salt analysis, and I am basically teaching you a very filtered down version of salt analysis, which is not even close to being enough for advanced, but might just fetch you marks in mains and NEET. So what I want you to do is listen carefully and follow my path. Basically, just write down what I am telling you, and to save your time, this time I have made the PDF before the lecture, and hence this will be around 20 minutes or so. And if you have any doubts, you can PM me on Reddit, or perhaps, no, I'm not giving my Instagram, but yeah. So that's it. Let's begin then. So what to study for salt analysis? Basically, what you have to do is the you have to study about radicals. So these are broken down into anions and cations. Now cations we also call basic radicals because they are metals, so basic. And anions we also call acidic radicals. So this we will do later, but first we will do anions. So here there we have two groups, A and B, and today we will be covering the entirety of group A in one shot. So let's begin. Before we do anything, I want you to know a concept which is sodium carbonate extract. So I'm sure you will be familiar with the concept of a test. A test is basically something we perform to make sure of the presence of a certain something in this compound. For example, if I want to check if this thing has carbon, so for that I'll have a different test. If it has sulfur, I'll have to do a different test. So those tests are what we study in salt analysis. So basically, there is no problem when the salt we are testing is soluble in water. Like it's written here, wet tests for anions. Wet test is basically confirmatory test, which means that you are suspicious that an entity is present in your solution, but you are not confirmed. So in order to confirm it, you do confirmatory tests. So confirmatory tests for anions are performed by using water extract. Basically, just that salt solution in water. When the salt is soluble in water, and if it's not soluble in water, we use sodium carbonate extract. What is that sodium carbonate extract? Note it down that we basically mix 1 gram of that salt with 3 grams of sodium carbonate, and this basically the carbonate ion does something which makes a sodium salt of the original salt, like some kind of displacement reaction takes place, and then we use that extract to perform our tests. So that was it about sodium carbonate extract. That's all you need to know. So let's begin then. Let's start with our anions, class A. Now, why are they segregated in class A and class B? Basically, in class A, you have to test with dilute HCl. Like the preliminary test has to be done with dilute HCl. What is the preliminary test? Basically, for all of these anions which belong in the first group, you have to use the dilute HCl in the solution. What does this do? With dilute HCl, each of these elements produce a different result, which can make you suspect their presence in the solution. And based on our inference from that, we are going to check for their presence via their confirmatory tests. But many people will start having problems from this point. How do I remember that carbonate ion, nitrite ion, sulfide ion, and sulfite ion is present in the group A? Many people have trouble remembering this also. So for those people, I have made this acronym, which is coconut is so sour. Is a filler word? It's not relevant here. You can also know coconut so sour. So what does this basically with cocoa? you have to remember carbonate, like C, C. You have to remember that. With nut, you have to remember nitrite. With so, you have to remember sulfide. And with sour, you have to remember sulfite. Now your question must be, why did I choose these words? So look at this. The oxidation state of carbon in carbonate ion is 4. So cocoa has 4 letters. So hence you use cocoa to remember carbonate. In nitrite ion, the central atom nitrogen has an oxidation state of positive 3. So nut has 3 letters, so you have to remember this using that. In sulfide ion, the central atom has the oxidation state of negative 2, but taking its mod, we have SO with 2 letters, and for sulfite ion, which has sulfur oxidation state as positive 4, we have sour, which has 4 letters. So coconut is so sour you can use to remember for group A. Now what are the preliminary tests for group A? Basically, let me tell you about the CO system. The CO system is a system that you can use to describe the state of any gas, like not in the thermodynamic way, but rather an inference way. So this C cross simply means that the gas does not have any color. O cross means it does not have any odor. C मतलब O tick means that it does have odor and the odor is mentioned below. And C tick means that it does have color and the color is mentioned below. So let's continue with that. The preliminary test, as I told you, you have to add dilute HCl to the solution, and based on your inference, like these are the inferences, like what kind of gas did you receive, and using the properties of that gas as a dictionary, you have to like guess which of these anions might be present. So we need to know those tests. So what are those tests? First of all, if basically in your solution you add dilute HCl and the gas starts bubbling out like this. So that is termed as brisk effervescence. And if that gas has no color and no odor and still you see bubbles on the surface, you have to start suspecting that carbonate ion is present in the solution. Now, if the gas has no color but suddenly you are hit with a rotten egg smell in the room, that means that the gas is actually H2S, hydrogen dihydrogen sulfide, and that obviously means that you have to start suspecting the sulfide ion. Now there is no way for you to cheat through this. You have to remember these inferences because that is what makes salt analysis. But I am trying to make it as easy as you for as easy I can for you as possible. So I want you to cooperate, and if if even this lecture is not helpful for you, you are free to leave salt analysis. Now, if the gas has no color but it smells pungent. Now, what is the pungent smell? The pungent smell just means it smells like an onion. Now, onion won't be mentioned to you because onion is something that I have added on my own account. Like I searched online what pungent means and it told me that it has onion like smell. So if salt analysis is it's basically an identification of keywords. So pungent as a keyword would mean that there is SO2 gas, and then you have to start suspecting the sulfite ion is present, which is SO32 minus. And the onion is something that I have added only for you to understand what kind of smell pungent means. And if the gas has brown color, that simply means that it is nitrite ion which is suspected. So let's do a quick recap. If the gas has no color and no odor and it shows brisk effervescence when dilute HCl is added to the solution, then carbonate ion is the suspect. If it has no color and instead has rotten X smell, then S2 minus is suspected, which is the sulfide ion, sulfide with a D. If we are having no color but a pungent smell, then we are suspecting sulfite ion with a T. And if there are brown fumes, which means that the brown color is not available, but damn, it's still not available. That makes me sad. But yeah, if there are brown fumes, that means that we have to start suspecting the nitrite ion. So that was it for the slide. Let's go ahead. Now let's learn the confirmatory tests. And with the confirmatory tests, I'm also going to teach you the chemistry of what chemical reactions cause the observations that we see. And this is going to help you understand the tests better. So for carbonate ion, you saw that we got brisk effervescence. So why did that brisk effervescence come? It came because this is our sodium carbonate. Like this is just the salt. We are testing actually for the carbonate ion, and sodium is basically just a spectator ion here. It does not do anything in the reaction. Oh, and a general point I want to tell you, in all of these tests, the dilute H2SO4, what does it do? It causes a displacement reaction. What kind of displacement reaction? Basically, you see that there is Na2CO3 here and there is H2SO4 here. So, H2SO4 causes a displacement reaction. How? This SO4 is now moving to Na, and this CO3 is now getting attached to the hydrogen. This is an example of a displacement reaction or perhaps a double displacement reaction. And what happens is that when this reaction happens, carbonic acid is formed. I forgot the name of this, but hydrogen carbonate, you can say, is formed, and basically this dissociates, not dissociates, but rather it breaks down into water and carbon dioxide. Now this carbon dioxide was the one which was causing the brisk effervescence. Now what is the confirmatory test? Like I have been suspecting that carbon dioxide is present and hence carbonate ion is present. What is the confirmatory test? How do I confirm that carbonate ion is present? So for that our test is that the if we pass the evolving gas, like from here gas will evolve. So if that gas which is evolving, I pass it through lime water. Lime water is basically its calcium hydroxide solution, that is called lime water. So if that gas comes in contact with aqueous calcium hydroxide solution, it forms calcium carbonate with water. Now this calcium carbonate is white in color. In fact, if you have seen an egg, the shell of egg is made of calcium carbonate. So which is why we call the solution as milky, because that color is analogous to that of milk. So this CaCO3 causes the milkiness, and we say that the carbon dioxide turns lime water milky, and this confirms the presence of the carbonate ion. But if we want to check for sure, then we should pass more CO2 through the milky solution, and after a certain point the milkiness will disappear and this will revert back to its original state. Why so? Because calcium carbonate, which was the result of our previous reaction, when it is reacted with excess carbon dioxide in the presence of water, it forms calcium bicarbonate. Calcium bicarbonate is soluble in water and hence it does not show any kind of precipitate like properties. So that was it about the carbonate ion. Let's learn about how we can check for the sulfide ion. Now this test is a bit harder, but stay with me. The sulfide ion is basically S2 minus. This is again that sodium salt of S2 minus, which is Na2S. And again you can see this is an example of a displacement reaction where H2SO4 takes away the sulfide ion and forms H2S, whereas this sodium takes away the sulfate ion and it forms Na2SO4. And this H2S, my friends, was the culprit of odor. Like in the preliminary test, we studied that on reaction with dilute H2SO4, the it forms a rotten egg smell. So that rotten egg smell, as I told you, comes from the hydrogen sulfide or H2S. Now, how do I confirm the presence of the sulfide ion? Now, you have to take a filter paper and you have to dip it in lead acetate solution. What does this do? When you take that filter paper dipped in lead acetate solution and you pass it through H2S gas, like H2S gas is brought in contact with this lead acetate strip, then what happens is that it reacts with the H2S to form PBS with 2 moles of acetic acid. Now, PBS, as you know, we studied in P block, this is called galena. And galena is in fact an ore for lead and also for sulfur. So this is basically the opposite of reaction where we extract sulfur from galena, and this is actually black in color. So if the solution starts becoming black, like there's black color starts forming here, then you know that you have confirmed the presence of the sulfide ion, because on reaction with lead acetate it has formed a black substance. So that is what tells us that sulfide ion is present. There is another test that you must know, which is the sodium nitroprusside test. Now first of all, let's look at sodium nitroprusside. What is sodium nitroprusside? Let's try to decipher it. Now this is the nitro here. This ion, which is the NO plus ion, we call it the nitrosonium ion. Alright. So the nitrosonium ion is a part of sodium nitroprusside, and of course there's sodium. And this is the prusside part. I won't go into the nomenclature of that. But you have to remember that sodium nitroprusside is nothing but a complex where iron is the central metal atom and surrounded by 5 cyanide ligands and 1 nitrosonium ligand. And the spectator ions here are the sodium Na plus ions. So what happens in this test is basically it's the reaction is quite easy despite its monstrous look. Basically we have Na2S here. Sodium is in +1 oxidation state, but for 2 sodium the net oxidation state of entire sodium is +2. But here sulfide is in -2 because it is sulfide ion. So all you have to do is basically it's addition. You have to add 2 plus 2 4 here, and this sulfur just goes inside. That's it. The sulfur combines with the nitrosonium ion to form NOS, or you can also call it sun. Basically, you can say that this is the sun. Like these were the parents, and this was the sun. And basically, instead of 2 sodium, it now has 4 sodium, and this remains the same as earlier, FeCN5. And the physical interpretation of the completion of this test is a purple or violet coloration. I have attached an image here, like this kind of beautiful purple color is formed on completion of this test, and this is what we call the sodium nitroprusside test. I hope you have understood this. Please take a moment and note it down. Let's move on to sulfite. Now, how can we test for the sulfite ion? The sulfite ion is SO3 minus. So once again, as I told you, a displacement reaction will take place when you add dilute H2SO4. We have sodium sulfite. When we react it with dilute H2SO4, these sodium ions take away the sulfate and form Na2SO4, and the hydrogen takes away the sulfite ion to form H2SO3. And just like in carbonate, we studied that H2CO3 breaks down into H2O and CO2. Here H2SO3 breaks down in H2O and SO2. Now, there's one point of distinction here, that SO2 also turns lime water milky. So how do we differentiate between the SO2 and CO2? So the true test for CO2 becomes this: excess CO2 gives calcium bicarbonate, right? Because turning lime water milky indicates both CO2 and SO2. So to confirm whether it is CO2, you have to pass excess CO2 and it will form a colorless solution. Now this is not a test for the sulfide ion. The NCRT lab manual mentions this, so I just added it. You do need not note it down. It's just a trivial point. But now, what is the actual test? When we pass this gas, the sulfur dioxide through acidified K2Cr2O7. Basically, this is a strip. It's a strip. We will, one second, we will pass H2S gas through this strip and it will form green color, like this color. K2Cr2O7 is normally orange in color, but on passing through this gas, it will form a greenish substance. What is that greenish substance? It is chromium sulfate. Okay, and acidified is important because dilute H2SO4 is still a part of this reaction, which is where the sulfate ions came from. So remember this color, that I'll even in fact use the color. This is a green substance, chromium sulfate, chromium sulfate, chromium sulfate, green, green, green. I'm saying it again and again so you will have a memory aid. And that was the only test of the sulfite ion we are supposed to know at mains level. Oh, and also one point I forgot to mention, that the SO2 gas, whenever it is present, it feels like it's suffocating. Like it will feel like somebody's choking you. Um, no, not in that way. It's like choking you. It will feel like it's suffocating. You know what suffocating means. So that was sulfite ion. Take a moment to note this down. Now let's look at the last ion for today, and which is the nitrite ion. The nitrite ion, again you can see a displacement reaction takes place, but since nitrite ion, instead of having a 2 charge, it has only 1 charge. So we will need 2 moles of its sodium salt to react with H2SO4. So here what happens, the sodium takes away the SO4 again and it forms Na2SO4. And what's formed here is interesting, it's HNO2. Now here look at the oxidation state of nitrogen. The oxidation state of nitrogen here is +3 if I am not wrong. And nitrogen, as we know it can disproportionate in any intermediate states it has between its maximum oxidation state and its minimum oxidation state, minus, which is 5 and -3 respectively. So HNO2 disproportionates, and basically this is the reaction of the disproportionation. You need to know that it breaks down into HNO3 and nitrous oxide, and nitrous oxide and on reaction with oxygen from the air gives nitrogen dioxide. Now this nitrogen dioxide is brown in color, and this brown in color, this was the result of the preliminary test, if you remember that. Like when we studied preliminary test here, this brown fume is caused by the nitrogen dioxide gas. And this made us suspectful that the nitrite ion is present. Now once we have this nitrogen dioxide gas, how do we confirm that it is nitrite ion? Basically this is the reaction. You can see I copied it directly from the NCERT lab manual. Basically it's reaction with 2 moles of potassium iodide and acetic acid, which forms a potassium salt of acetic acid along with the most important part, which is I2. Now what I2 does is it turns starch paper blue. Starch paper is basically an indicator which can be used to predict certain compounds in your solution, and you have to remember that iodine turns starch paper blue. So here when you add potassium iodide and acetic acid to your solution where this gas is present, that gas basically, actually not that gas, but you have to react it with the HNO2. When that happens, I2 is formed which turns starch blue. So take a moment and note this down. Now you will ask me one thing. What, how is this different from other videos? Like we study salt analysis elsewhere and you are doing the exact same thing. You are dictating the tests like you are Kim Jong-un. But actually, see, whenever you have to memorize something, the best way to memorize it is to create links between the content you have to memorize. So One of the best ways to do that is by writing a story. What kind of story? Basically, you have to write a story which has all of these ions as characters, and that will help you remember, because a vibrant, vivid story is easier to remember than a set of predetermined reactions and tests. It's boring. But I have made a story for you. If this is all you wanted to see, you can log off the video now. But I'll for the ones who want to stay, I can tell you a trick to remember these reactions. So let's begin with that. Now imagine there's this guy Coco, and he loves milk, but he has a nut allergy. These are crucial facts. Now here, right off the bat, you can see that cocoa is a reference to the carbonate ion. Like, you have to remember, you have to create a link that CO3, so cocoa, and loves milk. This is an obvious reference to the test of the carbonate ion. Look at your notes where it turns lime, water, milky. So right off the bat, we can see that these two are mnemonics for the carbonate ion and its confirmatory test. Now, why does it have a nut allergy? Basically, nut here is a symbol for the nitrite ion. Like you see, this is nitrite. So you have to remember NIT, NUT. So this is again, we are creating another link. And he accidentally drank a nut shake, but he had a nut allergy, so his face turned brown. Obviously, this is not practical, but it's a memory hit. And why did his face turn brown? Because on passing dilute H2SO4 through the nitrite ion, we get brown fumes. So again, this is a memory aid. This brown is a analogy to the actual brown we receive on passing dilute H2SO4 through nitrite. Now, of course, he wanted relief, so he gargled. But our Coco is a very clumsy person, and instead of water, he accidentally gargled with potassium iodide and starch. Now, what do you think will happen? You know that he accidentally drank nut shake and he has turned brown. So, he accidentally also gargled with potassium iodide starch. So, what happens now? He turns blue. Basically, our guy is very pure type of person. He loves rainbows, and from brown he has turned to blue because first he drank nitrite ion, then he gargled with something which was the confirmatory test of the nitrite ion, and then he became the embodiment of the inference of the confirmatory test of the nitrite ion. So this is how you can remember the test for the carbonate and nitrite ions in this one story. Now for the rest of the anions, let's start with this. Next day, our Coco wanted to go swimming. So what he did? He applied moisturizer on his arms and sunscreen on his legs. The moisturizer is lead acetate and the sunscreen is sodium nitroprusside. And he wanted to go swimming, so he wanted to jump into H2O. But by mistake, our Coco, being the clumsy guy he is, he jumped into H2S instead of H2O. Like H2S is a gas, I know, but here we are using it only as a link to understand and memorize this test. So, with lead acetate on his arms and sodium nitroprusside on his legs, when he jumped accidentally into H2S, his arms turned black precipitate and his legs turned purple. And he also started giving off a rotten egg smell. So, poor Coco, this has been a very unfortunate day for him. But then he tries to remove the rotten egg smell by applying deodorant. And his hair had gone bad due to the H2S. So, when he applied the deodorant, he forgot to notice that the deodorant had sodium sulfite. And the hair gel which he was applying to fix his hair had K2Ci2O7. So his final mistake was this, and hence, like, This is a very terrible story, but I would argue that it is peak fiction. Why is it peak fiction? Because it can help you remember all the basic tricks, all the reactions of class A anions. And while this does not look much, or it might even seem silly or obnoxious to you at first, once you read this, you will find it that this story is much easier to remember than individual reactions. And once you are well versed with this story, you can also create your own story and share it in the comments. Once you are well versed with these stories, these reactions will become no joke for you. I mean, they will become a joke for you because you will be able to easily relate these reactions with the story and you will be able to remember. Keep in mind that this video is only a subtle attempt to help you salvage your marks in practical chemistry, a topic which you almost gave up on. And let me know if this is helpful. I will upload subsequent parts soon. And that's it for this video. Thank you.